Hello everyone, welcome to my class. In today's class I'm going to cover graphs of sine functions, cosine function, secant functions and cosecant functions. So let me start the class right away. First let me talk about domain and range of sine and cosine functions. Quick recall, for any real number t, the coordinates of the point P x comma y on the unit circle corresponding to the angle t are the outputs of the trigonometric functions, that is cosine t equals to x and sine t equals to y. So in the diagram here, this is the unit circle and the point P corresponding to the angle t, the angle is at the center, we also call a central angle, then x equals to cosine t and y equals to sine t. So the first questions, let's ask to ourselves, what are the smallest and largest number that can be inputs and outputs of the sine functions and cosine functions? Since this t is coming from R, so the domain of the cosine t and sine t is all real numbers, and the range, the output of cosine t and sine t lies inside the unit circle. So the maximum is plus 1 and minimum is minus 1. Minus 1, plus 1. So the range is minus 1 to plus 1. Great. Now let's move on. Next definitions, even and odd functions. Function is even if f of minus t equals to f of t, and odd if f of minus t equals to minus f of t. So if we change t to minus t, if the function doesn't change, the function is even. If the function changes, then function is odd. Great. So for sine and cosine, let me talk about this diagram here. This P point corresponds to the angle t. If we change angle t to minus t angle, then the angle is in the fourth quadrant. Then using symmetry, the corresponding point of a P is Q with the coordinate x comma minus y. So the x remains the same, only y changes. So here y changes from y to negative y. So that means x is cosine t, y is sine t. So the cosine t remains as it is. Only the sine t changes. So the sine t is a odd functions and cosine t is an even functions. Great. So that's what I wrote here. Next, period. The smallest number p such that f of t plus p equals to f of t for all t in the domain of functions, then the p is called the period of functions. The period of sine, cosine, secant and cosecant function is the interval required for one complete cycle of the respective curve. The period of sine and cosine is 2 pi. Also secant and cosecant, their period also 2 pi. So sine t equals to sine t plus 2 pi and cosine t equals to cosine t plus 2 pi. In fact, sine t equals to sine t plus 2 pi times the integer k, and cosine t equals to cosine t plus 2 pi times the integer. Awesome. Now let's do some quick example. Example 1. The function sine t has a period 2 pi. That is, the 2 pi is the interval for sine functions one complete cycle. The function sine 2t has a period pi. There are two periods in an interval of length 2 pi. Here, period p equals to 2 pi over 2. So 2 cancels, only pi. Similarly, the functions sine of t over 2 has a period 4 pi. That is, there is 1/2 of a period in an interval of length 2 pi. Awesome. So again, we compute the period of sine t over 2 as p equals to 2 pi over 1/2. That means dividing by 1/2 is same as multiplying by 2. So then p equals to 2 pi times 2, which is 4 pi. Awesome. Now let me visualize quickly, though we have not done graphing the functions yet. So here I use graphing software to graph those functions. So here our sine functions is the green one, which has 0 at 0, 0 at pi, 0 at 2 pi. So it has period 2 pi, so it starts from here, and so the period is 2 pi. So then sine 2t, so we multiply the angle t by 2, then we compressed the sine graph, which is this red one. So this is one turn, another turn. Similarly in the next graph, we multiply the angle t by 1/2, or we divide the angle t by 2. Then the graph of sine t over 2 is this blue graph. So here we trace this sine curve. Great. So now let's move on. I hope this comparison will make sense to you later when we finish graphing the sine curve. Quick remark: the functions a sine of bt and a cosine of vt have period 2 pi over b and amplitude a. Note the amplitude equals to 1/2 times maximum minus minimum, and period equals to 2 pi over b, means these functions have b many periods in an interval of length 2 pi. Great. Quick example 2. The functions cosine of 5 pi t over 3 has no amplitude but has period 2 pi over 5 pi over 3. So you flip it, so 2 pi times 3 over 5 pi, which turns out to be 6 over 5. Similarly, the functions 5 sine of 144 pi t has amplitude 5 and period 2 pi over 144 pi turns out to be 1 over 72. Great. I hope it makes sense to you all. So now let's move on. Next, let's talk about zeros. Zeros are the values of t for which sine of t equals to 0 and cosine of t equals to 0. So the zeros of sine t are at t equals to 0, at t equals to plus minus pi, at t equals to plus minus 2 pi, and in fact the zeros of sine t are at t equals to k pi, where k is an integer. So these points are the zeros of sine functions or sine curve. So when you graph the sine function, these are the places where sine curve crosses the t-axis. Similarly, the zeros of cosine t are at plus minus pi half, plus minus 3 pi over 2, at pi half plus k pi, where k is an integer. Great. So now here, by looking at this two graph, the zeros of cosine t are just a shifting of the zeros of sine t here. So here zeros of sine t is at 0. You shift pi half to the left, the cosine function 0 is minus pi over 2. Similarly, this pi moves pi half, which is here. 2 pi moves 3 pi over 2, which is here. I hope this makes sense to you all. Now let's move on. Now we know the zeros of sine t and cosine t. Now next, let's talk about maximum values and minimum values of sine functions and cosine functions. In one cycle, the sine functions has maximum value 1 at pi half and minimum value minus 1 at 3 pi over 2. Here, as well as plus minus, these are at plus minus, these are at plus minus. So here for the sine functions at pi half, this is 1, and we know 0 is at 0 and is at pi, and minus 1, the minimum, is at 3 pi over 2, and again 0 is at 2 pi, and again 1 is here, and so on, similarly to the left side. So more or less we know the functions, maximum locations, minimum locations, as well as 0. So we are almost there to graph the sine function as well as cosine functions. Whereas in one cycle, the y equals to cosine t has maximum value 1 at 0 and minimum value minus 1 at t equals to pi. And also to the negative side, t is 0 as 3 pi over 2 and 1 at t equals to 2 pi. Great. Let's move on. Note, sine functions is positive and increasing on first quadrant, whereas cosine t is decreasing in first quadrant. So let me compare those values here. So we know this unit circle, and we know the point P with coordinate x and y is somewhere here. If P corresponds to the angle pi over 6, then the point is radical 3 over 2 comma 1 over 2. This radical 3 over 2 corresponds to the cosine x or cosine t, and 1/2 corresponds to the sine t. So that means in the first quadrant, this 1 corresponds to the cosine t value and 0 corresponds to the sine t value. So that means from here 1 goes to 0, so the decreasing. So the cosine function is decreasing in the first quadrant, and sine t is increasing from 0 to 1 in first quadrant. Let me visualize this part here. So all of the values are here. So here, this is my sine t graph in first quadrant. This increasing at pi over 6 is here 1/2. At pi over 4 is radical 2 over 2, which is approximately 0.77. At pi over 3, here radical 3 over 2, approximately 0.87. Those values I computed here. And at pi half, this is 1. So this is 1. So this is the sections of sine functions graph in first quadrant. Similarly, for the cosine functions, it's decreasing in the first quadrant. So here, at 0 degree, cosine t is 1, and at let's say pi over 4, this is 1 over radical 2, pi over 1 over radical 2 is here, which is approximately 0.77, and at pi half, the cosine t is 0, so cosine t is 0. So this is the graph for cosine t in first quadrant. I hope it makes sense to you so far. So now let me move on. Now we are almost ready to graph the sine function and cosine functions. Now a summary chart here. For any real t and integer k, the first column is the domain of sine functions, cosine functions, cosecant functions, and secant functions. The range of those functions, second column, their periods. All of these functions have period 2 pi. This is the symmetricity. The zeros of sine function is at k times pi, and zeros of cosine t is at t equals to pi half plus k pi. We have the asymptote for cosecant t and secant t increasing in those intervals. So sine function is increasing on 0 to pi half. This is the first quadrant, and 3 pi over 2 to 2 pi. This is the fourth quadrant. Similarly, cosine function is increasing from pi to 2 pi. That's the third quadrant and fourth quadrant. Great. I hope this chart makes sense to you all. Now let's move on. A table of values for t, this angle between 0 and pi, So sine t values, we are familiar with this table in our earlier sections. So from here we can see sine function is increasing in the first quadrant from 0 to 1. Cosine function is decreasing in the first quadrant from 1 to 0. Cosecant function is again decreasing from undefined to 1 on first quadrant, and secant function is increasing from 1 to undefined in first quadrant. Similarly, the values of second quadrant is here. And also we can easily compute the values in third quadrant as well as fourth quadrant using unit circle idea. Great. So now let's move on. Now we are ready to graph the sine functions. So example 3, graph sine t where t belongs to 0 to 2 pi. So let's see in the first diagram here. So the idea is draw the x-axis and label that x-axis as the t-axis, and draw the y-axis. They are crossing at a point origin. Mark that point by 0, and from 0 mark 2 pi along the t-axis to the right of 0. So here is a 2 pi. Similarly, in y-axis mark 1 unit up from 0 and minus 1 unit down from 0. So here and here. Now we have a rectangle here. This rectangle whose length is 0 to 2 pi and width is 2. This rectangle is also called reference rectangle. Then on the length here, mark in the half of 0 to 2 pi, which is pi here, and again half 0 to pi, which is pi half. Similarly, mark half of pi to 2 pi, which is 3 pi over 2. And then let's plot the values from this table here, and we know the maximum values of sine function in first quadrant is at pi half, which is 1, and the zeros of sine functions are at 0, at pi, at 2 pi. So these are the locations where curve crosses our t-axis, and minimum value is minus 1 at 3 pi over 2, and join those points. So then this gives us this curve. And in fact, using graphing software, the nicer looking graph is here. I hope this idea makes sense to you all. So it's a wave shape. Great. Now let's move on. Let's do example 4. Let's graph the 2 times sine t in interval 0 to 2 pi. So now here, so we are multiplying the output functions by 2. So we are stretching along the y-axis, but keeping the zeros as it is. So here, so only this height, the maximum and minimum changes. So now here's from here, the maximum was 1, minimum was minus 1. Now we multiply by 2, so maximum is plus 2, minimum is minus 2. The graph has the similar shape. The zeros are the same zeros here, 0 at 0, pi at 2 pi. And using technology, we have a smooth, nice looking graph here. Great. I hope this makes sense to you all. So now let's move on. Example 5, let's graph cosine functions. Solutions. We can proceed as above using the chart, and we can graph the cosine functions, or we can use the fact. In fact, the cosine t is simply the shifting of sine graph to the left by pi over 2 units. So that means, we already know the sine graph here. Then let's shift this graph by pi over 2 to the left. So here 0 moves to minus pi half, pi moves to pi half, 2 pi moves to 3 pi over 2, and then join. So this is our cosine curve. Both looking the wave shape, but only in different locations they cross to the t-axis, and at different locations they have maximum and minimum values. The still max is 1 and minimum is -1. Great. And I use a technology here to graph both sine and cosine function in the same plane, so which is here. Great. I hope this makes sense to you all. Now let's move on. Next, let's graph the functions of types y equals to a times cosine of bt. Let's pick a is 1. Example 6. Graph y equals to cosine t, cosine of 2t, and cosine of half t. We already graphed for the sine. Now let's graph here. So here's this is the cosine graph. Just follow the above procedure, then we will get the graph of the cosine t, which is this middle graph here. Then for the cosine 2t, means we are multiplying t by 2. That means we are shrinking the graph of cosine t, which is this one now. And similarly, the third function is cosine half of t. That means we are dividing the angle t by 2. So that means we are stretching the graph of cosine t. So which is this, the third graph. I hope this makes sense to you all. And again, using technology, we have this nicer looking graph of all these three functions in one plane, so that you can compare here. This is the cosine functions graph, this one, and cosine of 2t. This means we compress the graph of cosine t, which is this blue one. And the third function is cosine half t. That means we are dividing the angle t by 2. That means we are stretching horizontally, which is this graph. This is the stretching of graph of cosine t. Great. I hope this makes sense to you all. Now let's move on. Quick observations, maybe here. For y equals to a cosine bt, the period is 2 pi over b. If b is greater than 1, then this fraction is less than 2 pi. In this case, the graph has a horizontal shrink. Yeah, so here's the graph of cosine 2t is a shrink. If b is less than 1, then this fraction is greater than 2 pi. In this case, the graph has a horizontal stretch, we saw here, the graph of cosine t over 2. I hope this observation makes sense to you all, just comparing to the graph here. Now let's move on. Next, let's graph cosecant functions and secant functions. They are slightly trickier. Example 7, graph cosecant functions, the t between 0 to 4 pi, and we know the cosecant t equals to 1 over sine t. That is, the values of sine are reciprocated for the values of cosecant t. Quick table. So here's only the values of sine t and cosine t at those angles here. So in the first quadrant, the sine function is increasing from 0 to 1, where the cosecant function is decreasing from undefined to 1. Let's see here. We know the sine function graph is this one, right? And now for the cosecant function, let me put both together here. Yeah, so I can put these values here. So here, let's say at 0, sine 0 is 0 here, but cosecant 0 is undefined, so it starts from there, and at 30 degree, maybe here, at 30 degree, sine t is 1/2 somewhere here, cosine t is 2, sine 30 degree is 1/2 somewhere here, cosecant 30 degree is 2 somewhere here, and let's say at pi half, maybe this better, at pi half, sine pi half is 1, cosecant pi half is also 1, so that means they are tangent there, and at pi, sine pi is 0, but cosecant pi is undefined. Cosecant pi is undefined. So now we have this U-shaped graph. Now this is the vertical asymptote for cosecant functions, and similarly the other pieces of the cosecant functions graph we can find. So the U-shaped graph are tangent to the sine curve at sine's max and minimum locations. The U graph go on forever in either vertical directions. So let me use the technology here and draw the smooth looking, nice looking graph on my right side here. So this is the graph of cosecant functions. I hope this graph makes sense to you all. Now similarly, in example 8, we graph the secant functions, exactly the same idea. We first graph the cosine functions and then graph the secant functions, and we know the secant function is the reciprocal of cosine functions. So here in the first quadrant, again cosine function is decreasing from 1 to 0. So from the first quadrant, here's 1 to 0, this piece for the cosine functions, but for the secant functions it's increasing from 1 to undefined. So from here 1 to undefined. So the vertical asymptote for secant function is at pi half. Similarly, we can graph other pieces also for the secant functions. I hope this graph as well as other graph makes sense to you all. Now we finish the graphing sine functions, cosine functions, secant functions and cosecant functions. In our next class, we will graph two other functions. They are tangent functions and cotangent functions. Great. Thank you.